Amy, thanks everyone at Hack in the Box. It's always a great conference to be at, and it's always a cool city to hang out in. Every year, year after year, you guys tolerate me on the stage. So here I am again, once again for another hour on some of the kind of tricks that I've been working on recently and trying to make sense out of all this security stuff. Of course, also trying to stay into a job myself, given the situation of this year. Right. So, quick introduction, what are we going to talk about today and what I am going to be doing for this next 1 hour. This talk is mostly going to be a collection of tricks on how to take all your common exploits or uncommon exploits, how exploits have changed, how the whole process of exploitation has now moved forward, given challenges like DEP or ASLR or different things coming in and stopping us. We have to always find new ways to evolve. So one thing I'm going to show is what's the evolution in part of exploit scope, what are the avenues open to us. With this, how can we mass multiply our attacks? How can we quickly add up numbers and grab control of as much stuff as we can? Basically, for those of you guys who were in the other talk when Fyodor and Grug were talking about rubbish Russian stuff, I think personally they made up the entire talk, but if what they say is true, I know that it's true, they're really good friends. If what they say is true, botnets are being sold at $80 a day. You can buy a denial of service attack for $80 a day and take down something like Twitter. You can, rent credit cards, get passports scanned and whatnot. Now, how would you, let's say you want to offer these services, right? Yeah, run your own DDoS network for $70 a day and undercut the Russians. How would you go about doing that? You need to get a botnet, right? How the hell are you going to get a botnet? Well, I'll show you how. So what we're going to do in this talk is figure out how to assemble large number of computers together and control them. Quick introduction for me, just type Saumil in Google, that should be enough. Hit I'm feeling lucky and it will work. For now it will work. Right. So, coming to the topic of the talk, we're talking about world domination. We want to be on every computer, on every desktop. Same statement as Bill Gates made, right, when they started Microsoft. So how do we get onto every computer in every desktop? Before we do that, there's 4 areas that we need to understand and we need to look at. First and foremost, evolution. Never ignore this word evolution. Human evolution, technical evolution, evolution of processes, styles, culture. Evolution affects us all. Then we're going to talk about a little bit about what the next attack ecosystem looks like for this year and probably for the coming few years. How is the attack scenario going to look like? What are the fertile areas of attack and how can we continue capturing desktops? All depends on a lot of factors like what's the popular software out there, how do people use the internet, or what kind of desktops do they own, what are their habits, what kind of protection mechanisms are there. So we're going to talk about all that. Then what we want to see is how can we take our exploits and mass manufacture them, add them up rapidly and start capturing computer after computer very quickly. I mean, one thing that computers are really good at doing is doing repetitive things really fast. They don't get bored. Right. So coming on to evolution, a few trends that have shaped over the past few years. I'd like to point out specifically 4. Take a look at software and see how complex software has become. We've always been saying that, right? We've never seen software get really simple. People want to mash up everything. I mean, today, people want to be able to tweet and have their tweet location registered from Google Maps. They want to have their pictures integrated and do whatever they want. It's all about bringing everything together with a click, and that they want to do it from their phone, sitting on their toilet. So yeah, sure, software is going to be pretty complex, but on the facade of it, software looks really simple. I mean, look at Google's interface. It's just one field, you type stuff and it does stuff, and behind it is a complex beast. What are the chances that you're going to make mistakes when dealing with such complexity? Let me ask you this question: let's talk about secure coding for a bit. Right? I mean, people like me have been preaching secure coding for years. There's an old friend of mine, Pallav, sitting over there. He used to work with me. And he and I have been teaching classes and trying to drum it into people's skulls that, if you don't use string copy, you're like screwed, and man, you're doing select statements with addition signs, like how lame, how pathetic, grow up. Okay. For a moment, sit on the other side. Be a developer. Try to think, how easy is it going to be to write 100% secure code? It's not. The reason why I'm saying this, because last year we had to suffer a development project. 8 years we spent in breaking web apps. Last year we had to build one, and I said, screw it, never again. Even if it's a lot of money, I don't want to build a website. Because I'm continuously threatened that what if somebody does this or that. First of all, very little documentation is available. To be very honest, the only really good source of enterprise-grade documentation comes from Microsoft. It's MSDN. Nobody else does a good job of documentation. So how do you code? Cut and paste things and mash it up, use APIs. Now somebody has a problem, something's broken, so everything you've built on top of that is broken. Things keep on changing. There are some defensive trends coming in, but then the mistakes surmount the defenses always. Despite libraries, despite the static code analyzers being plugged into your dev environments and QA and unit testing, there'll be some goofball who will always make a classic mistake on top. And this classic mistake is universal. It's not like, even Google can make mistakes. Harun and I are both witness to a Gmail flaw, which they didn't patch for over a year. I think both sense post and we found it and kept being exploitable for over a year, and even Google didn't patch. Anyway, coming to user awareness. User awareness is rapidly sinking. Users don't have a goddamn clue what they're doing. They see a button, they're going to click it. What they see is what they believe. This is true. It's very easy to make users do whatever you want, right? Lastly, I do want to talk about standards. The quality of standards. It started improving, but until like 2002, 2003, things were halfway stable. Then the quality of standards started sinking. First of all, why the hell are we still at HTTP 1.1? When did this damn protocol come up? Came up in a nuclear testing facility underground below 3 countries in a ring, right? When was this built? 1990 something? I don't know. Protocol has moved only to 1.1. And what are we doing with this old, idiotic, stateless, and asinine protocol? We're running our internet banking on it, we're Twittering on it, we're iPhoning on it, we're whatever the bloody helling on it. We're doing everything on a protocol that was never meant to do this stuff. On top of it, you have anybody looked at HTML5? If there was a more ass-backward standard than HTML5, show it to me, and I'll definitely buy you a drink. The standard is around hundreds of pages long. I was looking at the number of JavaScript events. There's more than 400 different JavaScript events. There's did you move your mouse left? Yeah, there'll be an event for that. Did you breathe? There'll be an event for that. There's got tags like canvas tags have become increasingly powerful. You can embed codecs and run things right in the browser. So the path to exploitation is going to shorten up for sure. There's all sorts of talk about, oh, this whole same domain, same origin policy is really bothering us. It's not allowing us to mash up everything. So we're going to implement mechanisms which are going to selectively do away with same origin policies. Now these things, I guarantee you, have not been thought through properly. And sooner or later, there's going to be mistakes made. Like Harun said in his talk yesterday that, a few years ago, we used to poo-poo XSS, like, oh, cross-site scripting, what the hell, it's just popping up alert boxes. But now we know that simple attack vector, which used to be just once, alert document.cookie, now it's become really powerful, and now its impact has sort of grown exponentially. Sure enough, with HTML5, this is going to happen. They're talking about persistent storage. They're talking about online and offline database storage. They're talking about tearaway applications and whatnot. I'm willing to see that. I'm willing to bet that it's going to keep us in jobs for a very long time. Right. So, talking about the attacks and the open attack surface, what kind of attack surface do we have today? It's all mostly got to do with web. On the back end, it's port 80 or port 443 and whatever that lies behind these ports. So web applications, it's not about the web server anymore. A few years ago, we were talking about exploiting IIS-5 and Apache and Novell servers. Things have moved beyond the servers. Things have now gone into the back end, where that's where all the juice lies. That's where every developer makes mistakes in publishing their web app and bridging old legacy web apps together, and just getting code that runs. I mean, getting it run is a miracle, so you don't bother fixing it up. And most of our pen tests, I mean, we do pen testing as a company. Most of our pen tests are app pen tests, and there's not an app that hasn't been broken yet. I mean, there's something or the other and gives up the goal. That's where all the juice lies. On the desktop side, all your attack surface is now pretty much limited to just browsers, documents, libraries, media handlers, and any other fancy things you add on top of it, like Java applets, Flash, Silverlight, .NET, QuickTime, whatever you do, whatever elements that you can trigger by loading HTML code or by sharing documents. This is now your attack surface. So in summary, your attack surface is in three common areas. One is you have browsers. Most of our attacks are going to be browser based. And any plugins that the browsers use. We'll talk about browsers a little bit. Browsers are incredibly complex pieces of software. Coming to back-end applications, you have web applications, the business logic of web apps, and databases that lie beyond the web apps. And last but not least is you have documents. Documents, the attack vectors from documents are growing quite rapidly. These are not yet thoroughly explored only because the formats are proprietary. HTML has been beaten up in and out because it's ASCII text. You can read it, you can reverse it, you can read up whatever specs you have and you can learn it up. But it's not very easy to create your own Word document from the command line. You just can't like VI it and write tags and create your own Word document. You need to know how Microsoft implements it, or you just can't. It's difficult to make up your own PDFs as well. I'll say difficult. It's possible. We'll see some of those. But these documents are rendered by their engines. And what are these engines? Microsoft Office, Adobe Reader, Foxit, or whatever you may have. And soon all this is going to move online as well. So this whole document rendering and all the libraries that are available on documents, that's going to move into the back end. Google Docs, Office Live. What will happen if you have some bug in a document? There were quite a few bugs published. There was bugs with the JPEG parsing libraries. There was bugs in media handlers. Now, if any of your documents have embedded content, embedded pictures, embedded media, and you reference a vulnerable library, you can trigger an exploit by just simply viewing a document. And that's the third and pretty deadly attack vector because it's largely unexplored. So given this scenario, you have browsers, you have documents, and you have web applications. How can you begin spreading your wings and trying to grab every desktop? That's what we're going to try and make sense of. Right. Let me give you a quick preview into some of these exploits. Let me show you some examples of recent exploits, browser-based exploits, doc-based exploits. Web app exploits everybody knows, right? Everybody knows web hacking. Everybody's getting free internet in this hotel, so I'm not going to mention how to do it. Right. Let's come to browser attacks. What's a browser? I mean, what does a browser look like and feel like? What does it do? It's a complex piece of software. It's as complex as any operating system. There's lots of components, lots of moving parts. There's a network interface. There's this whole document object model in which you can load your HTML, load style sheets, and also load JavaScript. It comes with its own interpreter and interpreting language. An interpreting language that is so powerful it can modify the document object model itself. So you can write JavaScript itself modifies itself. You can write JavaScript to build up and add to your DOM or subtract from the DOM as you see fit. You can write HTML and JavaScript code which can also reference any plugin that you have in your browser. Any toolbar, any media handler, any additional framework like Java or .NET, all these can be referenced through various DOM interfaces exposed through JavaScript or other VB script or different scripting languages. This is what browsers look like. This is what every average user's browser is. It's not far from reality. You fire up any computer, you'll at least see 2 or 3 toolbars, you'll see a whole lot of system tray icons. Largely this stuff is not being used, but everything runs along your browser. Now when I say that a browser is pretty much like an operating system, you think of the toolbars, think of the plugins, think of all these as kernel drivers to your operating system. Think of the document object model as a kernel, think of all these toolbars as drivers and extensions to your kernel. Think of all the HTML as userland code. Think of JavaScript as your runtime environment. There is no security inside the browser space. If you do something, you can get control of the complete browser. It's as secure as DOS is. Everything in one flat process, kernel, userland, memory, everything is touchable by everything else. Last year I did a big rant on browsers and I just tried to prove my point that browsers suck when it comes to security. And I'm glad that they suck because I've got a job as an exploit writer for the next few years. We've seen some improvements in browsers. We've seen IE8, which implements a dual process model, so tabs run in a separate process. IE8 has done things like always opt in for DEP, so all your heap is non-executable. Of course, with the OS's address space layout randomization, the bar to exploitation is pretty high. There's Google Chrome, which is still growing up, but for some odd reason, people love it. That also operates on a dual process model. Firefox keeps on adding version numbers, but really doesn't do much. They still try to win our hearts by saying it's free and by using Firefox you're going to cure hunger in this planet and all that stuff. Whatever, man. And Apple is just completely blind to the fact that they can be hacked. I mean, we are Apple, we run a Mac. Who the fuck can hack us? No one. Well, grow up, guys. They will have to grow up. They've got no choice. So Safari is another popular attack vector. Let's see what let's see what the new wave brings. I'm pretty excited what we can do in the next year. But all in all, browsers still have a document object model. They still have a JavaScript interpreter. Any HTML can be loaded on your browser, and that HTML can do anything it likes with the entire browser space. That HTML can invoke a plugin if it's installed. It can fire up a QuickTime player. It can perform a search in your Ask Jeeves toolbar. It can load up a new Flash object, load up a new Java applet, add up a DOM, add frames, and keep pulling more stuff. There is no control that anyone has over what loaded HTML can do. I would say the only thing that even comes close to implementing browser security is the NoScript extension in Firefox. It's like wearing a t-shirt instead of running around naked. That's just about it. There's nothing else that anyone or anything does when it comes to browser security. Not Norton, not McAfee, not Microsoft, not Apple, not Ubuntu, no one. Still same ugly model. This can only change if somebody decides to proactively work on a better HTML and an HTTP standard. You've got to think it through and build in mechanisms to protect against browser exploits. Until then, you can raise the bar as much as you want, but there's always going to be possibilities. Like I wish I had a demo to show you. Probably will have one ready next week. A friend and I are quite close to getting exploits to properly run on IE8. Same old exploits, but yeah, IE8 makes life a little more difficult for the exploiter, but it can be worked around. There's issues like DEP bypass, which we can overcome using return-oriented programming. There's issues with ASLR, which we can overcome by just using multiple instances and choosing different addresses in every one. Like, why can't we open up 256 frames and use a different return address in every frame? One of the frames has to pop and things are fine. So we have a lot of helping hands when it comes to writing exploits for browsers. I'll show you. Initial work, pioneering work was done by, or let me at least say the pioneering work was properly collected and perfected by Alexander Soterov and Mark Dowd. If you're interested in browser exploitation, do read their papers. They've done a lot of good work. Some of their techniques are now defeated with new browsers, but well, it's only going to say that new techniques will come up. What are the kind of things we have which can help us for browser exploitation? We have, of course, JavaScript, and JavaScript as our friend. Up until 2002, I used to be able to surf the web with JavaScript completely turned off. It didn't bother me. 2002 onwards, it's impossible to survive the web without JavaScript. I mean, nothing will really work for you. JavaScript is here to stay. And it's unmitigated. JavaScript can touch anything. There's also a huge possibility with Java applets. I mean, with Java applets, you can write a classic attack which can hijack your entire document object model and transmit everything back to the host from which the applet was loaded from. I mean, people are always searching for bypassing the same origin policy when it comes to cross-site scripting. Why hasn't anybody done it with Java applets? We did it with Java applets. It works like a champ. You can inject a tag, you can inject an applet tag and have it load from your own code base, so you get a connection back. Let the Java applet open up a socket and transmit everything back. So we don't care. The reason why cross-site scripting is not popular with Java applets is two things. Java applets are ugly, really ugly. Horrible to look at, disgusting. I mean, the GUI is stuck in the Sun common desktop environment of the late 80s. It's that terrible. And Java applets are really slow. I mean, the moment Java applets load, it starts grinding your computer to a stop. I'd say Norton antivirus and Java compete when it comes to grabbing your processor and bringing it down. They both make your Cordio work like a 386. But that's why Java applets don't succeed, because they just take too much to load and run, and then there's this whole Sun icon comes in with a Java throbber, and people like me say, oh, get out, just close the page before it has a chance to run. That's why they don't succeed. But there's a huge potential. hint to exploit writers, Java applets still mark heap pages as executable. So if you're thinking of loading up your shell code and running, Java applets is the way to go. You just hope they get faster, so people actually wait for the exploit to run, not kill it before. Flash is another interesting thing. Flash can also be used for heap sprays. We don't get executable privileges in Flash, but still, we don't need it sometimes. We can use, I mean, if you're doing fancy things with, intelligent JavaScript detection, just load up a Flash object and spray the heap using Flash, and it's going to work. There's some restrictions you have to get around. Your shellcode and everything has to be purely alphanumeric, or else you'll have to inject it as some other object, some binary object inside Flash, which I'm still learning and trying to do. Flash has great possibilities. There's Microsoft Silverlight, and it's open source project called Moonlight, which you can have on, you can run Moonlight and Silverlight on all browsers, Firefox, Safari, and IE. I'm sure it can run on Opera as well, not tested it. But that offers a lot of possibilities of manipulating the heap and running your script. So if, a lot of talk going on this year about detecting heap sprays using, Microsoft Nozzle and some other technologies, and that will, try to police the JavaScript interpreter so that if it looks something weird, we won't do it. There's a lot of just-in-time stuff that's implemented. Screw that. Let them do all the policing. We'll just use Flash and Silverlight and just win until they wake up to that, and by then there'll be some other lunacy that will come and help us out. Right. For documents, you have embedded Visual Basic for applications. I mean, if you're if you're a Metasploit user, there's a lot of papers on how to package Interpreter DLLs as VBA. You can generate shellcode which makes it like a VBA package, package it inside documents and just transmit that around. That's a huge attack vector as well. .NET controls also. Let's see a browser exploit in action. Right? A moment. Okay. So here I have a Windows VM. Those of you who've taken the Exploit Lab class over the past 2 or 3 days, 3 days ago, you'll see this is pretty familiar. So all right, let's get doing this. So here's IE, and I'm going to load up a simple exploit in IE, which will basically, this exploit will just run calculator. Calculator has now become the hello world of all shellcode. That's what my friend calls it, SK. He says calc is the new hello world. So we'll do that. Any example you see on Milworm or something that have calc. By the way, Milworm's down. Right? Milworm went down at 1 a.m. last night. Is it back up? I don't know if anyone knows. But give me a moment. I have to read through my notes. There's a classic, this is the memory corruption bug, MS, oh thanks man, you have to bomb on me right here. Right. Try again. Hang on. Come on, making me look bad. Well, third time. Always lucky. Okay, obviously the demo gods are not with me today. Let me reboot this machine. It's the best thing you can do. So let me try another one. If not, we'll just go on to the next, of course. Reboot. Come back up. Okay, so we'll see that browser exploit when it feels like running. Meantime, I want to talk to you about another thing. Okay, we'll see the browser exploit. Then this slide is going to make a lot of sense. But question is, yes, we have the exploits, right? How do we take these exploits to the masses? How do we mass manufacture these exploits, and how do we start owning up a lot of numbers? How do we start grabbing every desktop? Well, there's a lot of things that can come to our aid. You can definitely use Google to search around for places to plant. Google is useful for everything. Google is useful for living. So you can use Google to search around and plant stuff, look for places to plant. You can also use Google to look around for really clever tricks, which we'll show you. You can now start using large networks and large connected users like Facebook or MySpace or now Twitter to start sending your attacks to others. Get people to see them and get people to click them. You can get pretty innovative in this. You can do it by means of some free apps, or you can just start pushing out URLs. You can use SQL injection techniques and just do mass SQL injections in backends and plant your HTML code in the backends. You can use cross-site scripting, but cross-site scripting is a little slow. If you use cross-site scripting coupled with one of these MySpace or Facebook things, if a bug exists, you can multiply it pretty fast. But there's many ways of using these things to get your attacks out to a lot of people. Recently, last year, we've seen a notorious growth in the use of URL shortening services. Bitly, tiny URL is good. There's so many URL shortening services. Users all over the world have now just come to click on them when they see them. Previously, we used to give advice that don't click on a URL without looking at it. If it says like myhsbcbank.com.example.org.in or something like that, it's not going to be HSBC Bank. But now with the URL shortener, you never know. You can never look at your status bar. You can never right-click, view source. All these things go to hell. The only way you know what it is to click on it. And the moment you click on it, you're done. But now everybody's come to use these URL shorteners. People are posting pictures of funny cats in coffee cups saying, haha, look at this, it's bit.ly 33234. And somebody's just going to go and click on it, and that's it, that's done. Sadly, these URL shorteners are here to stay. They're not going away at all. What can we do about that? I don't know. I have no idea. Right, let's see if that demo wishes to run and give us some blessings. Right. Make sure the backend is okay. Oh yes, I know what was wrong. Bad shellcode. All right, now it's going to work. It was not a problem. Okay, put in all right, if luck goes, we have a calculator with us. So we have this, right? Well, that's the easy part. Now, how do you get how do you get a URL like this? Let me increase the font size so you can read. Yeah, here's the URL. Okay, so assume this is the URL. Now, what can we do with all this? Let's see. One of the really cool things you can do is, let's assume we have a vulnerable URL over here, right? Script hackers.org xss.js, common cross-site scripting testing script that we all use. You know what this thing does? Google in URL print.asp $URL equals HTTP. What's this going to do? We are looking for resources on the internet that will take a URL as an argument and return it us through redirection 302. Usually it's like, pretty print this article, so it's like print.asp $URL equal to blah blah blah. Let me show an example if the internet still works. Let's get that going. What we're trying to do is we're trying to use other websites to be our URL redirection services. We just give it an argument. Let's say somebody is not happy with this URL, like phpdemo.example.com. If you're looking at no script, it's going to try to block it. And let's say you still want this thing to go in. Then here's what we should do is check this out. This is Google. There. The internet is slow. All right. Let's search for in URL print.asp $URL equals HTTP. Yeah. Search for this. Now you're going to see a lot of URLs come back. I mean, check this one out. phf.org.uk print.asp URL equals phf.org.uk. So whatever you give over here in this URL argument is going to be merrily redirected using a 302 response. So now you can have your script as something like this. Say HTTP. Let's click on this guy. Print.asp. Okay. Keep an eye on the top address bar whenever it loads, if it decides to load, because okay. Now check out, the URL was print.asp and now it's become something else. Let's use this one. Let's just use this, print.asp URL equals google.com. You do this and you get Google's page, of course, with a couple of arguments added in. Now, if you use something like this in a script tag, if you do something like, script source equals blah 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 reader.asp, reader.asp URL equals HTTP. Goddamn dashboard. HTTP. Script tags will obey 302 redirects. They'll keep on fetching until the tag loads, which is really interesting. So you can use redirection to disguise your script tags, the origin of the script. And as if this was not enough, you can bitly the whole thing down into one. So double redirect, triple redirect, as many times as you want. And then you just do script source is equal to is good, whatever it is. And this script will be rendered and this script will work. So that's how you start hiding your sources. Now, once we've got our attack vector set, how do we populate to the masses? And let's resort on some classic web hacking. We can always use SQL injection, cross-site scripting, XSS worms, anything in the user land HTTP level to get our code thrown out to the whole world. This was one of the screenshots of a tool that was planting a lot of mass SQL injection attacks. This tool is basically running Google queries for in URL ASP and A equals to. It's pulling out all the pages which have some parameter, something like, I star.asp A is equal to 29, F3 F.asp A is equal to 18, and all these parameters will be tried for SQL injection. If it succeeds, it succeeds. If it doesn't, move on to the next. So this tool just keeps on harvesting URLs which may be potentially SQL injection candidates and just hits it. If it hits, it hits. If it doesn't, it doesn't. What does this SQL injection do? It injects a script tag in every varchar, in every row, in every table, in every database of your backend with a single SQL query. It's pretty clever SQL. I personally am allergic to SQL, but over the years I know I've learned is you can do a lot of things with cursors and stored procedures and whatnot. So you can create your own proc and then use that to inject into every, enumerate the information schema and use that to inject into every character field on the entire database that you have. And if this script hits, what it's going to do is all the data that is generated from the backend database will now have your JavaScript added to it. Here's an example of a daily newspaper in my city, ahmedabadmirror.com. Got hit. This stayed up for around 7 or 8 months before the donkeys even knew they were hit. So if you look at this text, you won't see anything. There's some announcement of a Japanese movie festival and all that. But look at this path marker. You see, all of a sudden, one of these fields you have script source is equal to http iwdown.com e.js. Now, e.js is an unpacking, obfuscated malware delivery mechanism, full of common exploits. It delivered 7 or 8 exploits. Here's an instance where it actually didn't render properly because of probably some formatting and all. But if it, in these cases, in these fields, it has rendered properly, you browse to it. If you're vulnerable to one of the 5 attacks that it is serving out, you're done. You're owned and infected, and then a Trojan will be installed on you right there. Here's an example of the whole injection vector. This is the SQL code of what it does. So you declare some cursor procedure thingy, whatever it is, and what you do is you append your own script tag. Script source is equal to whatever URL you have, appended to every column which belongs to a user table and its data type is varchar across every object in the database. This is what it does. Let's give it a shot. Let's see. We've got another candidate SQL injection site, so we're going to use that one. So here's a typical site, stuff that I use in my trainings all the time. Pallav knows this one quite well. We still use the same thing. See, things haven't changed. All right. So here's ID is equal to 2, classic SQL injection. You all know how this works, and you break it, and then go yay, we can break it. Let me see, or 3 equals 3. Get all the fun stuff, get your jollies out of it. Right? Okay, that's fine. But now let's put in this big, massive SQL injection vector in there. Let me pull it out. So here's the whole thing written in one line, and then here's the same thing which is encoded by URL encoding. So we're going to copy this, it's all just hex characters, nothing else, and simply attach it over here. Simply paste it, cut and paste the whole thing. If it sits and it works. If it doesn't, it doesn't. Went in, it didn't give me an error back, which means this thing has been populated. The attack script, what is the script? Here's the script that we tagged in, php demo.example.com, redirect x is equal to j. This is just a JavaScript redirector that I have. Now let's see what happens to this guy when we load up IE again. I mean, this is just an IE example, but totally depends on the browser and the vulnerability that you're targeting. It could happen to Firefox, it could happen to anything. Depends what you have. So all I have to do is now just go to the site, and with any luck, I'll get a calculator popping up. It's already going to work. There's like 4 or 5 instances probably running. And with any luck, we'll get a calculator come up on the screen. There. Okay, so this is how you get code running just by site visits. That's great. There's another area of attacks which still is a really good area of attack, and that's documents. As if just browser attacks was not enough, documents are really fertile ground for attack. Especially since Adobe decided they want to include JavaScript with their document reader. I mean, why does Adobe want to include JavaScript in their PDF readers? PDF readers are supposed to bloody print documents exactly as they appear so that we don't have to own printers. We're not going to run JavaScript in PDF documents, but Adobe doesn't get that. You look at the size of the Adobe Reader install, 170 megabytes, 200 megabytes, just to view a document. I mean, it's insane. But there's a whole lot of goodies combined in PDF documents. I guess Adobe has that Harry Potter vision. They want to make books that have videos and wizards popping up and all that. So they're packaging all that stuff in there. You have a Flash to PDF bridge which is already bundled. You have an Air to PDF bridge, which again we still need to take a look at. But if you're interested in PDF attacks, one of the talks in this room earlier was on PDF origami. Great stuff. Another guy who's done a lot of good work on PDFs is Didier Stevens. Read his blog, and you learn. You know, this word penetration document format is Didier's copyright, and I'm using it without telling him. Okay, now the kind of obfuscation and dirty tricks you can pull with PDF. Okay, let me show you. Here's 2 PDFs I have. Right, they can be delivered over Twitter, or they can be delivered over, email or whatever it is. Let's just double click one of these. I mean, here it's a nice comparison between a stone and an iPhone. Yeah. So, but I've programmed this PDF that you can read it for 10 seconds, and then after 10 seconds, boom, blows up and gives you calcs. Now this PDF is, if you actually look inside a PDF, I assembled it manually. I'm going to just give you a very quick view of the PDF. So here's a PDF. It's basically text with embedded images and JPEGs and whatnot. If you go through the headers, you can inject your own open action tags in the catalog. This means that run action number 666. Action number 666 is a JavaScript object, and the JavaScript here is you have all this shell code. It's the same shell code as I used to run calculator, but it's triggering an Adobe vulnerability. There's 4 or 5 of these Adobe vulnerabilities out. Adobe is notorious in patching them. They just don't get they don't get serious about patching. They take like 3 or 4 months to patch a bug. Now, it's very easy to defeat antivirus. I mean, this PDF, I actually emailed it to myself on Yahoo today. It's like today's date. Draw the inferences. Not an antivirus. Confidence in a connected world. All right. Download the file and merrily use it. And this is what you're going to get if you use it. Simple. I mean, if you read through this code, all I've done is replace %u with woot woot and then just replacing it in line. And then the attack vectors like, app.collab.getIcon is just replaced with this AAs and BBs. You can see I'm just replacing partial strings in here. This is enough to defeat the signatures. I mean, Greg and Fyodor were talking about the Russians guaranteeing you exploits that are not detected by antivirus. The moment not an antivirus picks up the signature, just change 2 or 3 bytes here and it's going to be fresh again. You can do that pretty easily. And even this is actually a multi-part exploit. This is an exploit that works for, it's 2 exploits in one, the Adobe Get Icon and Adobe Collab Email. And I can take a decision based on some variables, like if, I have to read my own code because I obfuscated it. But if my version is less than 7, then use bug number 1. Yeah, here. If version is less than 8, then do this. If version is greater than 8, do that. And you can launch multiple of them in one. Last but not least, I mean, calcs and all is cool, right? I mean, there's no, that's funny, makes us laugh and all that. But let's talk about some real payloads, real badass payloads. One of the badass payloads is something called download and execute. I have a binary that will be downloaded and executed the moment a vulnerability triggers, and that's what I'm going to do. Now, rootkits are also getting history. Well, not history, they're changing shapes. Evolution is modifying rootkits. Your classic rootkits used to be network sniffers, keystroke loggers. I mean, if it's Andrea, then he doesn't need a rootkit, he just needs a laser gun and electrical circuits to trap your keystrokes, which is really cool. But you don't need any driver level stuff in rootkits anymore. Why? Because life exists only on the browser. The OS is useless. So if I can infect the browser, that's enough. And what I'm going to do is I'll just infect a toolbar. Inside the browser, I'm free to do anything. I'll trap all your keystrokes from the DOM. I'll monitor all your sockets. I'll just monitor all your DOM traffic and JavaScript events, and I get everything. And all this can happen in a nice ActiveX toolbar or a nice Firefox plugin or a nice whatever extender that you may have, which you can download and execute stealthily. So here's one. Keep an eye on this. What I'm going to do is show you a toolbar that we wrote, which will create a directory in this documents and settings administrator, a new directory, and capture everything over there. It could very well be transmitting it back, but just for demo purposes, it's capturing. And you have to manually turn it on, but otherwise you can program it to automatically turn on. So here's the same PDF, which will force a download and install the toolbar. So again, back to Stone versus iPhone with a different payload. The moment it blows up, we will see a new directory being created over here. Okay, it's in the process of blowing up. There it goes, blown. And now, there we are, new directory called data capture. Let's see what's in that directory. Let's just surf around. I'll show what has now happened to Internet Explorer. You go to View, Toolbars. Okay, there's a hidden toolbar which we will now enable. We can unlock the toolbars to give you a better idea. So here's the toolbar. Now whatever I can do, let's say I go to if it loads up. Okay, so it's loaded up. Everybody's on the free wireless. Okay. So now, let's say I'm trying to log in. Yeah. Okay, there. And I'm going to say capture data. Click. This is a one-shot capture. I can also do auto capture. Auto capture will capture everything as we go along. Try signing in. And let's see what happens over here. Here's a log file being built. And now every key that I type, so here's what I typed in the DOM boxes, it tells me the fields and everything. And of course every URL, every cookie, wherever I go, whatever I do. And so now we're going to hack in the box. And once the page loads up, there you say now you've gone to hack in the box and these are your cookies, all the Google ads and whatnot. So all this data can be captured. No antivirus is going to detect this. This not even a rootkit. It's not hooking anything. It just lives inside the DOM and grabs your browser where the sun doesn't shine. So, well, what can we do about security? This is the last minute I have. Sadly, other than antivirus, user education, this is the only form of security we have. Security by pop-ups. I know we've in an effort to make everything easy for the users, we've made them into click monkeys. Whenever they see a pop-up, they click and just move on. So we'll have to learn about some new things. Basically, this brings me to the end of my talk. Questions and comments or anything. We have 1 minute left, and I'm sure the organizers may give us some more time if we'll play nice, right? So anything you want to ask me or discuss or throw light on or challenge or rant, rave, you're more than welcome. Yes. You want the PDF? Oh, sure, man. Just download it from the server, right? Ignore the calc, that's okay. Yeah, I'll give it to you. Okay, no problem, man. Yes.
Regarding one of your past projects, I believe it was called Teflon.
Yeah.
So how did the progress go about that?
To be very honest, my past project Teflon was an attempt to try to secure the browser. Stress on was because I gave up. It sucked because I was trying to police the JavaScript and all, and then I realized there's so many different avenues that can be used to defeat it. So unless the browser core changes, you're not going to see luck. So I abandoned it. If you want the source code, you can have it. Right, but it's not pretty good. It doesn't stand a chance against certain advanced exploitation.
But let's say half of the shell codes today you see are actually utilizing heap spraying. So
sure,
it does actually come in handy to a certain extent.
Right. Your question, your statement's valid. If the shell codes use heap spray, it comes in handy. Yes, we can detect heap sprays. There's two things which we are not really good at detecting through Teflon. One is any return-oriented programming. That's pretty deadly. So if you have just returns, return to libc type of stuff, you're just going back and forth between the stack and the DLLs, just like pop execute a function and all. No way you can detect that. Second, if you do a heap spray using Flash or Silverlight or Java applets, you're done. Now the game is to do a heap spray in something else. Use a plugin to do a heap spray and trigger the exploit somewhere else. And that's now becoming the norm, and it's going to be perfected pretty soon. Some of these PDF bugs that were live from various sites around the world, these were actually using a PDF to Flash bridge for such exploitation. Now you'll have like heap spray in one and trigger in another. So it will give up. Plus you can do heap sprays by just loading up JPEG files. Right? You don't even have to have JavaScript to do a heap spray. A Flickr page is a heap spray by itself. You're loading 80 photos on a screen. They're all going to occupy the heap. So I can embed my stuff in JPEG files and just load 100 of the JPEG files. That'll work too. Questions? There you go. All right. Thank you very much for your time and attention. Have a good evening.
Thank you, Saumil. As usual, one of our more popular speakers. Ladies and gentlemen, we're going to hook up the next speaker, our final speaker for the track, and we will come back to you in 3 minutes. In the meantime, we are still selling the post-conference party tickets for those who will be joining the party this evening at 9 p.m. with us at the loft.